In this video, I'm going to look at two different examples for subtracting rational expressions. The first example is straight subtraction, and then the second one we're adding and subtracting. So we have three different fractions. So for this first example, we have x plus 1 over x squared minus 6x minus 16. And so our first step is always to change our subtraction into addition. So what I mean by that is that for my first fraction, my numerator is going to stay the same in this first step. For my second fraction, however, because I'm subtracting, I'm going to distribute my negative and turn this into addition. So that means that my second numerator is going to change into negative x minus 1. So when we're looking at subtraction, again, that's our first step, is just turn it into addition so that that negative doesn't accidentally not get distributed to that second piece of our numerator. Then we want to look at our denominators and factor them. So we're doing a product sum because each of these are quadratic trinomials. For the first one, we have A is 1. For the second one, A is 1. So these are the ones where it's a little bit quicker. We don't have to use grouping. So I'm going to multiply 1 times negative 16, which is negative 16. And I'm looking for two numbers that add to negative 6. So remember the process of this, we're thinking about factors of 16. So for example, 1 times 16. I know that the 16 has to be negative because I want it to add to a negative 6. This one, however, adds to a negative 15. So I know that that's not the answer. So we're going through in our heads, okay, then 2 times negative 8. And good news, this one works. And so that means that x squared minus 6x minus 16 factors to x plus 2 times x minus 8. We're going to do the same thing with the second denominator. So this denominator, I need numbers that multiply to 1 times 8 and add to 6. And so that's going to be 2 times 4. So 2 times 4 makes 8. 2 plus 4 makes 6. So this is going to factor to x plus 2 times x plus 4. So what we want to do next is identify the least common denominator, which is the least common multiple of the denominators, right? So those two statements mean the same thing. And so what I'm looking at is, what do these fractions have in common? So both fractions have an x plus 2 in the denominator. And so I know that my common denominator has to also include that x plus 2. Then I can see that they each have something else left over. So I know that the first denominator has this x minus 8, which means that the second fraction is going to need to be multiplied by x minus 8. I also see that the second fraction has an x plus 4, so that tells me that the first fraction is going to need to be multiplied by that x plus 4. And so when I'm creating this common denominator, I'm multiplying both the numerator and denominator by those missing values. I'm just going to rewrite this so that I have some space to multiply. So I've got x plus 1 over x plus 2 times x minus 8. And so this first fraction is missing the x plus 4. So I'm going to multiply this by x plus 4 over x plus 4. Then I have the second fraction, so that's plus negative x minus 1 over x plus 2 times x plus 4. This denominator is missing the x minus 8. So I need to multiply the numerator and denominator by x minus 8 so that I'm not changing the value of the fraction. I'm just changing the fact that they now have the same denominator. So my denominator is now x plus 2 times x minus 8 times x plus 4 for both of my fractions. So what that means is that I can simplify my numerators and write these as a single answer. So I'm going to multiply my numerator. Since they're both binomial times binomial, I have to distribute each term. So if I distribute the x, in the first one I get x squared plus 4x. And then if I distribute the 1, I get x plus 4. I want to do the exact same thing with the whole second pair of binomials. So I'm going to distribute negative x, so minus x squared plus 8, and negative 1, so minus x plus 8. In that last one I missed, so my negative x times negative 8 was plus 8x. I, for some reason, just wrote plus 8. So then I want to combine like terms if possible. So I have a lot of like terms. Notice I have an x squared and a minus x squared. Those are actually going to cancel out to 0. I can do the same thing with an x and a negative x. So really I'm just adding 4x plus 8x, which is 12x, and 4 plus 8, which is 12. So I have 12x plus 12 over x plus 2 times x minus 8 times x plus 4. So a simplified fraction always has a factored numerator. So what I want to look at is, can I factor 12x plus 12? And I can. Both terms have a 12. So if I factor out the 12 from here, I'm left with x plus 1. Unfortunately, I don't have an x plus 1 in the denominator to reduce. And so that means that my answer is just 12 times x plus 1 over x plus 2 times x minus 8 times x plus 4. I want to look at B because our denominators are very different. So we've been looking at things that we can factor using product sums. In this problem, we can't really factor these other than think about it as like 3 times x, or 6x as 6 times x. I can even break down 6 as 2 times 3 times x. And then x squared I can only think of as x times x. And so when I'm doing this, to find my LCD, I'm thinking more about what factors they have in common still. But in this case, my factors are just single entities. So these two have a 3, and then all 3 of them I can see have an x. So I know that my LCD is going to have an x times 3. And then it also needs to include the leftover pieces, which are a 2 and an x. So for this, I do simplify. So I'm not going to leave this as x times 3 times 2 times x. The way that I left the last denominator as x plus 2 times x minus 8 times x plus 4, because it's easy to multiply these together, and it's easy to see if something reduces with a single term, because this is just 6x squared. Okay, so I can still reduce this pretty easily using that value. So when I'm finding my common denominator, I want to create a denominator of 6x squared. So I have to think a little bit harder for these. So I'm going to copy down my problem and leave myself space on the right of each fraction to create my common denominator. For the last one, because I'm subtracting, remember that means that we want to change it to plus negative 1, still over x squared though. So as I'm creating my common denominators, I'm comparing those denominators to what I need. So I have 3x, I need 6x squared. So I have 3 and I have x, that means that I'm missing the 2x. So multiplying by 2x over 2x will make my denominator 6x squared. Similarly, for the second fraction, I already have 6 and x, and so that means that I just need another x to create x squared. For the last one, I already have the x squared, so I just need to multiply by 6. So I'm multiplying each fraction by something different so that all of them have a denominator of 6x squared. For my first numerator, 2x times 1 is just 2x. My second numerator is 1 times x, so I'm just going to add x. And then my third numerator, I'm doing plus negative 1 times 6, so that's just going to be minus 6. So looking at that, our numerator is going to be 2x plus x is 3x minus 6 over 6x squared. So just like in the last problem, we can factor out a number between our terms. So we have 3x minus 6. Those are both divisible by 3. So if I factor out a 3, 3x divided by 3 is x, and 6 divided by 3 is 2. So that's going to leave me with 3 times x minus 2 over my 6x squared. And so remember that the 6x squared is a product, right? It's 6 times x squared, and this is 3 times x minus 2. So I am able to reduce the 3 over 6. So if I divide 3 by 3, I get 1. And if I divide 6 by 3, I get 2. So that means that the final answer for this one is 1 times x minus 2. So just x minus 2 over 2 times x squared. So that one did reduce in the last step. So nothing changes between adding and subtracting except for in that first step when we change subtraction into addition by changing the plus and then changing the signs of the numerator. So when there's more than one term, you have to make sure that you don't miss those multiple